on the shark bite.
Where's your location?
It's on both boards, actually. This shows the location, but we'll talk about that in a second. On the shark bite, which numbers do we want to see? Do we go over? Have questions about? Is that 2, 4, 5 or there? Okay. 2, 4, 5. So I saw 2, 4, and 5, but some of these can also be done in desmos, so we'll go through those as well. Okay. No one asked about one, but to show you in desmos, if you plotted both points, you could count the slope. You could also find the equation of the line and make sure that is your slope. So if you got -2/3, that was correct. For number 2, you had to make a table. So make a table, and then it's asking using the line of best fit, so make your line of best fit, which is the closest to the length of time it should take her 6-year-old niece. So you could put in x equals 6, see where they intersect. 199.5, the closest would be 200. So B would be your answer for that one. Three, if you know what the y-intercept is in the problem, you don't need desmos, but let's say you forget or blank on the SOL, you could always put it in desmos. And look and see where does it cross the y-axis. 4. So 4 is another one. It's a right-in equation, so you should be putting in y equals mx plus b. It'll ask you to add in sliders, add in all of them. It's perpendicular, so I put in the point in the original equation. The original equation's slope is -1/5. So if it's perpendicular, we have to take that and flip it and make it positive. So our slope would now be 5. And we're looking for, when our slope is 5, where does it go through that point? And at -7, I didn't write that equation. So that should have been the equation, y equals 5x minus 7. Questions on that one? And then 5 was graphing that inequality. So it should have been a dashed line, y-intercept of 2, slope of 3/4, positive, shaded underneath below. Okay, questions about that or any others? Okay, so we're going to go through the SOL packet, show you the answers and how you would do them on Desmos, and then the SOL 8 we're actually going to talk about and learn today. So after we go through that, you'll be able to go back and compare and refine the answers. So write down the answers first. So for SOL A7E, the answers were 82 and 325. For number 1, you can write all of this, or you could just write the answer is B. We'll talk about that here in a moment. The part underneath that, the answer was about 2 days. So I would write in all of this. Two was also B. Three, the two ordered pairs were the first one and the last one. I'm going to go through desmos on those and then continue. And we'll keep going until you see 70 at the top. Okay, 7E, you could have put in the original equation, made it into a table, put in the two numbers it gave you for the domain, since it's asking to find the range of those values. That would help you. You could also put in x equals of those two and find where they intersect. But you'd have to zoom out a lot. So either or. The first question was asking something about inversely, and as you'll see here in a moment, inversely is the one that looks like this, which is why it was that answer. Part 2, we were using the equation from part 1 to answer it. And if I put in the equation, I put in the numbers, it said about 1.6 repeating, which was about 2. But we'll talk about how to actually do that here in a bit. Two was the same, similar, except this one was where it was directly proportional. And anything that's adding wouldn't be. I want to say it's the black one, not the blue one. I think that's what I said. Yeah. And we'll talk about why that is here in a moment. Three, if you plot all these points, you're looking for which one would fall on the same line, but also go through the origin. And I said it was -10, -4. What was the other one I said? 5 and 2. So if I'm looking at those points, it looks like it's going to go through the same line and go through 0, 0, which is why those were the ordered pairs. But again, we'll talk about that in a bit. Number 4, once you figure out what a direct variation is and what to look for, you're looking for an equation that goes to the origin, that's a line, so this would not be a line, this would be a line, but it doesn't go to the origin, this is a line that goes to the origin, these are not lines. The graph that is a direct variation is this one, it's a line that goes to the origin. 6, same thing, a line that goes to the origin. 7, part A, the 3 points that would create a direct variation equation are 416, 312, negative 2, negative 8. So if you want to write the math underneath, you can. I'm going to quickly show you this in Desmos. This is the one that had all the different ones, so anything that doesn't look like a line, you could get rid of. And then anything that is a line but doesn't go through the origin, you could also get rid of. And that would help you find that. If I'm looking at all the points, the one that would make this into a line, and I kind of have to zoom out, would be 416, 312, and negative 2. But we'll talk about how you could also find that algebraically. Part B, you don't have to rewrite this, but you can if you want. These are the same order pairs from the previous page, but it's asking for inverse. So the 3 that would create an inverse are negative 4, 3, negative 6, 2, and negative 1, 12. I would just write those order pairs here. Eight was another select 3 points, but this one was direct, and the 3 were 3.57, 4, 8, and 8, 16. Nine, you had to plot 2 points that would make this a direct variation. So using the point that was given, it has to go through the origin, and you can choose any other point. So plot any 2, you don't need all 5, 4 of them. Now you could check this one in Desmos, but this would be one you'd have to know what it looks like, how to find it. Anyone still need this stuff? Ten was another one. It gave you one of the points, and you had to plot 3 points. So the origin was a good one, and then 2 others. Then for 11, the question is actually on the next page, so I'm going to go through that page. And it asks, is there a question for 11? Not really, okay. But which statement is true about the relationship? If you graph these 2 functions, you'll get 2 different things. So I plotted the points, and I graphed the 2 functions that were in the answers. One of them is going to match it. You have to know which one that is and what it looks like. So your answer for that one would be D, because it's that curve and it has the correct equation. a lot of the direct and inverse, when checking it, you can use desmos to find. SOL 9 was all of your line and curve of best fit, so I'll show you the answers and then show you how you can do them in desmos also. So 1 was D, 2 was B, 3, the value when x is -4 was about 2.33. Number 1 is pretty self-explanatory. Put them in the table, find the line or curve of best fit. I do want to point out one thing. That when you go to put them in, you should see that they curve and don't make a line. That would tell you curve of best fit, not line of best fit, so quadratic. 2, when you put them in, and it's asking about a specific place where those intersect, the number is not even close to one of your answer choices, but 11 point whatever it was is the closest. Three, when you put those in and do your x equals -4, just find out where they intersect. And that's how I got that one. Or part A was y equals 3x squared plus 2x minus 8. B, y equals 200. And then those, put them in the table, find it says quadratic curve of best fit, so use that regression, put in when x equals 8, and you would get that answer. 5, the answer was D. Without even really graphing this, you could figure this out because it makes a curve, so it can't be linear. So it has to be C or D. It's facing down, which means your A value has to be negative. So all the things that we've been learning about. And then 6, it asks you to use the curve of best fit to make a prediction when x is 13 months. So this was the quadratic curve of best fit that came from these points. And then you didn't have to do this algebraically, but if you put in x equals 13, you would get 1389. Do we need or want to see any of those in desmos? The last one, this dealt with years. Remember, anytime you're dealing with years, the first one you have to change to 0. Every year after that is how many years has it been since the original. In this case, it starts at 2000, so all the numbers are going to match whatever year it is. And you would put those in instead of the 2000s. Find your line of best fit, and the answer was D. And then as of today, you know your SOL is the 19th, which is exactly 2 weeks away from today. Just about all of you are taking it in the library. If you're not, I'll be talking to you at 7:40 in 2 weeks on Friday. As we get closer, I'll be talking more about, like, you'll need your laptops, charge, something like that, but we'll talk about that next week or the week after. Yes.
Is it going to have the school laptop?
Yes. All right. So So now you have completed this packet. Even if you didn't do all of it, you should have all the answers. You could go back and try them in Desmos. You should be practicing. So when you have free time, you're doing that. Right. As I mentioned, today is the last day. We are learning new stuff. So you have two packets. One is on direct, one is on inverse. Find the direct first. And then once you know the direct, inverse makes it a little bit easier. Okay. A direct variation is a specific relationship in which there is a constant ratio. That ratio is y over x. The direct variation equations are written in the form y equals kx. K is like your slope, but not at the same time. K is also known as the constant of proportionality. You might see that on Khan Academy as that. The ratio comes from solving this for K. And do that off to the side. So if I wanted to get K, I would get rid of X by dividing it. So as long as you remember, this is your direct variation equation, and this is how you find K, that will help you a lot on these problems. So we're going to go through different problems. So here, we have to find K. If it's the same, it has to be the same in order for it to be constant. Otherwise, it's not constant. Or direct. So for this one, we're going to use that ratio and divide 4 over 1, 8 over 2, 12 over 3, your y over x for each of these and make sure they're all the same. As you divide them each, they all become 4. So that would be your K value. Then we could use that to write our equation in this format. Just y and x, those stay the variables, and 4 becomes our K. Questions so far? As we were going through the SOL review, I kept saying it has to go through the ordinate. That's another thing that you may see in ordered pairs or tables. Because let's say we start doing the same process. We start dividing -8 over -12. What would that be? And then I keep going, -4 over -6 is also 2 over 3. 0 over 0 isn't that, though, as a special case. So based on just our rule from before, you would say, okay, it's not direct because it's not constant. But because it goes through 0, 0, if I were to count the slope between each of the points, it would be the same. So this is still constant. So then how would we write the equation? So that's one thing you have to keep in mind, that even if it doesn't divide correctly and it's 0 over 0, it's still direct. Questions about either of those? Finding the constant from ordered pairs or table? There was a problem on the SOL packet where we had to tell whether it was direct or not just by looking at the equation, or you could correct it. So if it matches that format, y equals kx, it is a direct. So would 5 be direct? Yes. And then it says if it is, what is the k value? 3. Is 6 direct? Yes. What's the K value is 7 direct. No, because that one doesn't have an X. 8 we would have to solve first. Divide both sides by 2. Is this direct? Yes. Because you could rewrite it as y equals 5 over 2x. What about 9? Lacey, you're saying no. Judy, you're saying no. Why? There's a number in front of x, so that part doesn't really matter, but something else. I need the -4. So if we look back at our original equation, if this was compared to our y equals mx plus b, what's our b value? It would be 0, and here it's not 0. So it always has to be 0 no matter what. Skipping to 11. If I solve for this, divided both sides by 2, is this direct? Yes. Because we can rewrite it as 1/2 x. 12 we would have to solve. Get rid of your x term. Divide everything by 2. Is this direct? Because of that negative. Right? Really, anytime you see this format, unless one of them is 0, it's not going to be direct. Questions on how to tell from the equation if it's direct or not? Go on to the next page. So we talked about how to find if it's direct from the equation. Now we're going to do it from a graph. Rules still apply. K value, or the slope, has to be the same between all your points. It has to go through the origin. Is 14 direct? Yes, it goes to the origin. The K value is the same. What is the K value? 0/2. What about 15? Is that direct? No. It is a line. The constant is the same, but it doesn't go through the origin. So keep that in mind when you're asked about these problems. I know we're moving fast. Do we have any questions so far? We're going to skip these and go on to the next section. Now, we're given a set of ordered pairs, and we have to find the missing number. So to do that, we're going to set up our K equation of what's given. So -4 divided by 2. That would be our K value. So we could set up our equation with just that first. Y equals -2x. Then in the other order pair, put in the number you have and solve for the missing variable. So our y value would be what? 12. To make sure that we are on the right track, that we did this right, we could divide these two and see if we get the same K value. If we do, it's right. If we don't, you got to go back and fix it. Questions about that? We're going to do a couple more examples in this one. So we found the y, let's find the x. Divide 16 and 4. How would we write that into an equation? What would that direct variation equation be? now we're solving for x. Our y value is 24. So divide both sides by 4. So x is what? 6. And if I check that, 24 divided by 6 is 4. The checking piece is not necessary, but it is a good way to double check yourself. Okay. 22 through 25 are the same type of problems, but they have more words. So let's do 22 first. This would be like your first order pair. So go ahead and divide that. Make sure you're paying attention to which one's x, which one's y. Sometimes they switch. What would that equation be? Y equals negative 6x. Negative 6 is k. And then we're looking for x when y is 30, so put 30 in for y and solve for x. What is your x value? -5. And then one more of these, 25. Go ahead and divide these. You're going to get a fraction. What would that fraction be? So then our equation would be y equals 1 over 4x. Now we need to find y, and we have our x, so put in 20. Figure out what y is. What would our y value be? 5. Right. Any questions on how to find the missing value? Go on to the next page. It's always y divided by x. Right? I think I took this box out. So when we use direct for word problems, if the things go up or the things go down together, then it's direct. So like the more time you study, usually the better you do on a test. The less time you study, the less you do, the worse you do on a test. Worse. The more time you spend practicing, the better you are at whatever you're practicing for. The less time you practice, the worse you are at whatever you're practicing for. Things like that. So as one variable goes up, the other goes up, or as one goes down, the other goes down. They have to go up or down together. Most of the time, you won't have to figure that out, but sometimes you will. So I'll show you how we can do that. For the first one, the sales at a baseball game, very directly, I'm going to underline some important words and we'll come back and talk about it. If the sales for a game are 12,000 when 800 people attend, determine how many people attend if the sales for a game are 15,000. I cannot read today. Okay. Anyway. So this amount went up. This says very directly, so the other amount should also go up. But if it gave you two sets of numbers and they both went up, you would be able to see that's direct also. So a lot of the times you'll see words like very directly, varies directly, directly proportional. All of those mean the same thing. What's nice about this is the way we solve the other problems is really the same. We just have to figure out how to set it up first. Whatever comes before the words varies directly is going to be your y, always. Whatever comes after is your x. So then when I see sales, anytime I see amounts of sales, that's going to be a y value. And when I see number of people, that's going to be x. So with these, the biggest thing is not confusing y and x and knowing what you're solving for. So since we know x is number of people, that's what we're looking for, x at the end. So as we were just doing, you would use the two that are given to find k. What would that be? 15. And with the word problems, your k value is, you could kind of write it like your slope. This would be dollars per person, is how you could think about that. Then you could use your k value to write an equation, y equals 15x. We're looking for the amount of people, so x, and we have 15,000. Put 15,000 in for y. And solve for x. What would x be? 1,000. And because this is a word problem, we need labels, so 1,000 people. Right? Just like before, if you want to double check yourself, you could divide these two and you should get the k value. Do you have any questions on how to set up or solve or get the answer for a direct variation word problem? Jaden, did you have a question? Let's do another. Number 2, ounces of medication vary directly with the weight of a patient. If a 120-pound adult requires 3/4 of an ounce of medication, how many ounces are required for a 200-pound adult? Okay. There's those words again, vary directly, so it tells us what we're doing. Ounces of medication comes first, so that's going to be your y. The weight of the patient would be x. So 120 pounds is x or y. X. 3/4 of an ounce of medication would be x or y. Y. And then how many ounces, what are we looking for, x or y? And then 200 is x or y. So now let's find our k. Using the first two numbers, I would put this in as a decimal instead of a fraction, that way you don't have a fraction within a fraction. So 0.75 over 120. Calculate that, and you get 90. And that would be ounces per pound. That seems. It was 90. Okay, I was going to say, that seems a lot.
I think this is a lot faster.
What was it? That seems more reasonable. think about these, like, that would be a lot of medication for someone. Alright, so that's your K value. Use that, write our equation, y equals 0.00625x. We are looking for y, put in 200 and see what you get. What was our y value? 1.5. That makes sense for the 200-pound adult. It should go up, so 120 went up to 200, 3/4 went up to 1.25. They both went up together. Right? We're going to do one more on this and then switch to inverse. Do we have any questions about that? We're going to do 5. Right? Here, you see the income of a computer analyst varies directly as the number of hours worked. So income is Y, number of hours is X. It tells us the amount earned, that would be our Y, and the amount of hours, so X. What are we looking for here? And that's it. So find K, and that's your answer. $32, and this would be dollars per hour. Okay, so pay attention to what the question is asking, because you may not have to do a bunch of work. Okay? Now that we know all the direct stuff, inverse is basically the opposite. Okay? So go on to inverse. It was $2.56 divided by 8, and it was $32 per hour. So if direct was a ratio, inverse is a constant product. X times y, y times x, either or doesn't matter. The inverse variation equations are written in the form y equals k over x. Same as before, if we wanted to solve for k, what would we do to get k by itself? Multiply both sides by x. Which is why I looked at that. Not that it matters, but. Okay, so just like direct, when you find the constant k, it has to be the same between all the points. So if we start with number 1, we are multiplying them together. So if we multiply them together and we get the same thing for each one, that is our k value. What would we get for each of these points? So then to write our equation, it would be y equals 20 over x. Let's do a table example, 3. Multiply your x's and y's. So wait, you just stopped. That's our equation, that's it. Okay. And now this would be negative 12, this would be negative 12. Is this first one negative 12? So that is our k value. How do we write that equation? not going to need to know how to graph it, but I'm going to show you one example so you see what it looks like, so you remember what it looks like. For this example, it tells us our constant is 16. So in order to get 16, they would have had to multiply two things together to get that. How many factors of 16? 1 and 16, 4 and 4, 8 and 2. There's a reason I'm spacing this out. Because we could also write the opposite. Because when we go to graph these, we'll need all of them. So 1, 16, 2, 8, 4, 4, 8, 2, and 16, 1. Plot all of these points on your graph. Be careful because it's counting by twos. And you'll get something that looks like this curve. You're going to connect the dots and make this curve, draw arrows at the end. But when we found 16, we only looked at the positive values. Negative times a negative is also a positive, so we could do these same values, but make them all negative. And plot those as well. That's also going to make a curve, connect those points, and draw a line through them, drawing arrows at the end. So again, you won't need to know how to graph this, but as long as you know that whenever it makes that shape, that's inverse. Questions on the graph? Go on to the next page. In this section, 7 through 14, we're going to do a few of these. Similar to the direct, but the rules have changed. We do still have the ordered pair. We are still missing one, but now we're multiplying instead of dividing. So multiply those two. Tell me what you get. So that's our k value. In our equation, we could write that as y equals 168 over x. Then in the other ordered pair, we have x, we don't have y. So put those in. Figure out what your y value is. To double check here, you would take the x value and y value and multiply them. And you should get the same k value. I'm assuming that was 168. Okay. Questions on that process? Yes. Yes, that's the difference. So direct is divide, inverse is multiply. So all this stuff basically. All right, let's do another one of those. 10. Here, the first set of ordered pairs is not the one that you have both, so just do it for the second one. Multiply those two. Negative 63. So your equation would be what? Negative 63 over x. It's always k over x.
Oh, but we're looking for x.
Yeah, we haven't gotten to that yet.
Okay.
So now we are looking for x, so we can put 7 in for y, negative 7 in for y. How would we solve for x? Multiply. And then divide both sides by negative 7. What is x? No. And then I can double check. 9 times negative 7 is negative 63, so that's questions on that? Do 2 more of these and move on to the word problems, and then we're done. Okay. 11, same thing, same process, but now it's in words. Take the 2 first numbers that you have together, multiply those, what would you get? 54. Your equation y equals negative 54 over x. We are looking for x and have y. Something you could also do, it would basically be the same, is put 3 over 1 and cross multiply, which would basically be the same as multiplying by x, so it doesn't matter. Same amount of steps. What is x? Divide in your calculator, see what x is. And if I double check, negative 18 times 3 is negative 54, so that works. 14. Multiply the numbers, what do you get? Positive 56. What's our equation? So the regular equation without anything else would just be x, and then we're trying to find y, so we would put in the negative 4, which would give us what for y? Negative 14. Questions on how we find the missing value for inverse? On the next page, I don't have this up here, but I know you have the box up here. If direct goes up and down together, what do you think inverse does? The opposite. So as one goes up, the other goes down, or vice versa. The more time you spend playing games, the less time you have to do homework. Things like that. I'm bad on the numbers today. Great, so let's do 7. Same with direct. It will say varies inversely, inversely proportional, something like that. Or it'll give you 4 numbers and you have to know whether they go up or inversely together. Whatever comes first is still your y. So that part's nice. Second part's still your x. So if a train travels between 2 cities in 3 hours, 3 hours is x or y? Y. At an average speed of 65 miles per hour, that would be your X. How long, so what are we looking for? Y. And we're given the average speed. So same as before, find our K value using the two numbers given, multiply those. What would that give us? Say that one more time. 195. Our equation would then be y equals 195 over x. Since we are looking for y, we can put 78 in. What is our y value? And is a word problem, so what label? Hours. So what we can see is starts at 3 and starts at 65. The amount of hours goes down, the average speed goes up. So that would be an example where they're opposite. Do we have any questions on how we set that up, solved it, got the answer? Let's try 9. What is your y? What is your x? Width is y. Length is x. So we have the width is 4, and length is 18. We need to find the width, so what are we looking for? Y. So go ahead and find your K. Girls, stay. What's your K value? What's your equation? Okay. Since we're looking for y, put 8 in for x. Nine. There wasn't a you say units. Usually it'll say feet or whatever, but this one didn't say. Last one, 11. Virginia. Sure, don't worry. What's x plus y? Okay, so we have a y, we have an x. What are we looking for? Okay, so multiply those. How much you get? So notice I wasn't putting the whatever per whatever in this case because it's not slope, it's a little different. So you can just put the number for these. Do we have any questions in general on direct or inverse variation? I tried to go through that as quickly as possible, but efficiently as possible, so you guys would have a little bit of time to work on Khan Academy. So the remainder of time is yours to work on practice or Khan Academy.